Okay, good evening. Welcome to
FamilyMath568.
So we're going to continue on do a very similar project on the Shannon entropy as we did yesterday. So, what do you remember from our project from yesterday?
Well, we looked at how many times the deck needed to be shuffled in order to be mixed up well.
Yeah, and how many was that?
I think it was around 7 or so.
I said 7 was optimal.
Yeah.
Well, it kind of like hovered around at when you got to like 3.5 entropy.
Yeah. So we got to by the measure. The absolute number actually is not as important as where it settled down around there. But different measures of entropy are going to produce different numbers. But overall, one thing that was interesting is the surprise that you can actually measure disorder. There's a way to do it. So you can mathematically tell when something's shuffled. So today we're going to try a different method of shuffling. And rather than the riffle shuffle, I don't know the name of this kind of shuffling. I mean, one thing you could do would be to just sort of spread the cards all over the place on the table and just mix them all up. Right? But can you demonstrate for the camera the kind of shuffling you're going to do?
So I'm going to do 3 of them at a time. And
You're in good.
it's just like you take part of the deck out of the middle, put it on the end.
Okay. And then mix it together. And then take part of the deck out of the middle.
Put it in the end.
Okay.
Like that.
Alright, so here's our first shuffle. And now, before we go through the same procedure as we did yesterday, if I remember right, our entropy on the first riffle shuffle went from 0, perfectly ordered.
Yep.
And I think it was around 1.5.
1.6 maybe.
1.6, okay. Do you think this type of shuffle is going to leave us, after one shuffle, more ordered? So lower entropy or higher disorder?
I think it's going to be a lower.
Okay, how come?
Because
all you're doing is, in the riffle shuffle, you're kind of spreading the cards out so that no groups are ever touching each other. In this one, you're just taking a group and putting it on the end, so there will still be lots of groups left, unless you do it a lot.
Okay.
yeah.
So I think this will have lower entropy.
So we're defining one round of this as 3
Yeah.
shuffles. So you think this will have lower entropy? And what do you think?
I think this is going to have lower entropy too.
Okay, how come?
Well, because of the same reason. You're taking existing groups and just moving them around.
Okay.
I mean, there's some groups are going to get destroyed, but not all of them.
Okay. Well, let's, with the camera off, we'll enter the numbers into the computer and then we'll come back and talk about it, okay?
Alright?
Okay.